Let's recall from the previous video the application of the Poisson distribution as an approximation to the binomial distribution. So what we said is that the Poisson distribution with parameter lambda can be used to approximate the binomial distribution with parameters n and p, where lambda is n times p, when n is large and p is correspondingly small. So what it means is that the binomial PMF can be approximated. The binomial PMF evaluated at k is approximately the same as the Poisson PMF evaluated at k. Okay, so we are now going to do an example. Let's let n be the number of letters on a page. Each letter typed is either misprinted or printed correctly. So for each letter, either it is misprinted or correctly printed. I'm going to label a misprint as a success or S, and correct print will be labeled as a failure or F. Let's let P be the probability of a misprint or a success, and X be the number of misprints on a page, or number of misprints among n letters on a page, or in terms of my labels, X is the number of successes. So clearly then, X is a binomial random variable with parameters n and p. We are going to assume that lambda is we're going to take lambda to be n times p and assume that n times p is equal to half. Now remember, n times p is the expectation of X. So recall n times p is the expectation of X. So that means on average we expect 1/2 or half misprints on a page. So on average we expect half misprints per page. So what's the probability that X is at least 1? Well, the probability that X is at least 1 means that the probability the probability that X is greater than or equal to 1 is the same as the probability that the number of misprints is greater than or equal to 1. Well, that's the same as 1 minus the probability that the number of misprints is less than 1, which is the same as 1 minus the probability that X is less than 1, which means 1 minus the probability that X is 0. So this is here. We are going to write the probability that X is 0. Now instead of using the exact probabilities, we are going to we can find the exact probability that X is 0 by using the binomial distribution, but we are going to approximate it by using the Poisson distribution. So what's the probability that X is 0? Remember, the Poisson PMF is e to the negative lambda to the k over k factorial. So P of 0 would be e to the minus half times half to the 0 over 0 factorial. Here lambda is half, so what we get is 1 minus e to the negative half at the end. Okay, so that's one example. Let's do another example. Let's say that the probability that an item produced by a company A is defective is 0.1. That is, each item is either defective or not defective. The probability that an item is defective is 0.1, and so then the probability that an item is not defective is 0.9. What's the probability? We want to find the probability that a sample of 10 items will contain at most one defective item. In order to answer this question, let's let x be the number of defective items in a sample of 10 items. Then what we are looking for is the probability that x is at most 1. The probability that x is at most 1 is the same as the probability that x is 0 plus the probability that x is 1. Remember that x is the number of defectives. Here we have 10 items, so n is 10, and the probability of a defective item is 0.1. So here lambda would be lambda here would be n times p, would be 10 times 0.1, which would be 1. Now we are going to calculate these two probabilities in two ways. First of all, I'm going to use the exact probabilities. That is, we're going to use observe that x is a binomial random variable. So the exact probabilities will be the following. So the probability that x is 0 is 10 choose 0, 0.1 to the 0, 0.9 to the 10. Probability that x is 1 is 10 choose 1, 0.1 to the 1, 0.9 to the 9. So here we are using the exact probabilities for x. So here we are using the fact that x is binomial with parameters 10 and 0.1. So we are using the PMF of the binomial distribution. And what we get is 0.7357. Now if we use the Poisson approximation instead, so what we're going to get is, so here we are using the Poisson distribution with parameter lambda equals to 1. So here we are thinking of x being a Poisson random variable with parameter lambda equals to 1. Now this is an approximation. So we are assuming x is the distribution of x is approximately Poisson. In that case, the probabilities will be e to the negative 1, 1 to the 0 over 0 factorial, e to the negative 1, 1 to the 1 over 1 factorial, because we are using the Poisson PMF. Again, we get 0.7357. Now these two numbers aren't really the same. They will differ a little bit if we look at enough many digits. But what we see here is that the Poisson distribution is indeed a good approximation to the binomial distribution. Okay, so I'll see you in the next video.